Alright, so we are now recording.
Leave me alone, Ryan.
Alright, and we're going to talk about odd and even functions in terms of symmetry, not degree. Okay, there are two ways to determine symmetry of a function. One is algebraically, the other is graphically. Graphically is probably easier because you just look at it. And if it passes the test, you know what it is. Algebraically is not hard though. What we do algebraically is whenever we're trying to determine symmetry, if we plug in the opposite of x into our function, and we get out the original function. So what this means is we're plugging in the opposite, and we get out the original function. Then we say that function has even symmetry. Okay, so an example of one that we could do this way, if we said f of x equals x squared minus 5. This function has even symmetry. And the way I would prove that is to plug in f of negative x into this function. So wherever the x was, you put parentheses and you plug in a negative x. And when we do this here, f of negative x, what we get is x squared minus 5, because when we square a negative, it becomes positive. Now, compare f of negative x to f of x. They're the same, aren't they? So, when we plug in the opposite and we get out the original, or we get out the same thing, then we could say algebraically we have proven that the function has even symmetry. And we call that even. Okay? Now, how would we do this graphically? Now, if you think about this function, this is a parabola that's been shifted down 5 units. Do you remember parabolas?
No, not really.
Okay, well, I'll sketch one for you real quick then. Okay, so when we look at parabolas, this one's been shifted down 5 units. So when I go to graph it, I would come down 1, 2, 3, 4, 5. And then if I go left and right 1, 1 squared is 1, left and right 2, 2 squared is 4. And if I could draw it perfectly, which I'm terrible at, we would see that graphically this is symmetric to what axis? The y-axis. Okay, so that's how we can tell looking at it. If it has even symmetry, it is symmetric to the y-axis if we're looking at the graph. So we ought to be able to fold it down the y-axis and it folds right on top of itself. Okay? Now, the next symmetry we're going to study is odd. Now, algebraically, if we plug in a negative x, what happens is we get the opposite of the original function. It's not the same. So when you plug in the opposite, every term switches to the opposite. Okay, I'm going to move this little even graph up here, and then I'm going to put an example of odd here. Okay, so here's an example of an odd function. G of x equals x cubed minus 5x. So what happens with this function when I plug in a negative x? Okay, so whenever we plug in into the parentheses. So we have negative x to the third minus 5 times negative x. Well, what is negative x to the third? It's negative x to the third. Because a negative to an odd power stays negative. A negative to an even power would become positive, like it did up here. But a negative to an odd power stays negative. Now what happens when I do negative 5 times negative x? It becomes positive 5x. All right, so do you see that with this function, when I plugged in the opposite of x, every term, they only had 2, but both of them switched signs. I got the opposite of the original function. So that's how I know, algebraically, I have proven that g of x has odd symmetry. Now, graphically, the way we prove this is we could say point symmetry about the origin, or this makes me think of it rotational. Rotational symmetry about the origin. And it's got to be the origin. Okay, so what that means is if I rotated the graph 180 degrees, 180 degree rotation around the origin, then it falls right back on top of itself. Okay, so let's look at some of these graphs. And with these graphs, we're supposed to determine from the graph, does this function have even symmetry, odd symmetry, or it's neither even nor odd? Now, honestly, most functions are neither. Most functions are neither even nor odd in their symmetry. We have to be very specific to come up with a function that does have even or odd symmetry. Now, do you see that if I put a push pin right here and I flip this around 180 degrees, that it would fall right back on top of itself? Okay? So which one is this? Even or odd? Odd. Okay? Do you see this one? If I folded it right down this y-axis, it would fold on top of itself. Yeah. So what kind of symmetry does that have? Even. Now, this one's tricky. It looks like this function would have symmetry, but not in our algebraic definition of symmetry. Because if I fold it down the y-axis, do you see that those points aren't going to fall on top of themselves? It is not even. It does not have even symmetry. Does the function have some symmetry? Yes, but we cannot describe it as even nor odd. Okay, so this would be a neither. All right, let's go look at our algebraic examples. Can you confirm algebraically if these equations are even, odd, or neither? Sure we can. So, in each case, now let me warn against what some tutors might do. There are some tutors that will plug in +2 and -2 and say that's okay. Well, sometimes that can give you false positives or false negatives. We have to plug in positive x and negative x. Okay? So if any of you go outside for some extra help, when you get to your tutor, just go ahead and put a note right here. Miss Willoughby says I have to plug in positive x and negative x because there are lots of special cases I could create where +2 and -2 would give you incorrect answers. I'm not going to do that on purpose, but I do want you to be aware. Now, understand the reasoning behind that, because +2 and -2 are opposites, right? And that's why it does help us to see it, but it doesn't always tell us the truth. All right, so we're going to plug in negative x. We're going to plug in negative x. And we're going to plug in negative x. Okay, so what you're going to notice on this particular problem Because every term is raised to an odd power, every single one of these terms is raised to an odd power. So in this case, f of negative x, this is going to become negative x to the fifth. A negative times a negative is going to be a positive 5x to the third. And a negative times a positive is a negative 4x. Let's check out every single term. Opposite, opposite, opposite. Odd, even, or neither? Odd. This function has odd symmetry. Okay, this one. Let's plug in the opposite. And see what happens. If you were asked to explain why you would say this has odd symmetry, you would say it has odd symmetry because f of negative x is equal to the opposite of the original function. That's what that means. Because when I plugged in negative x, I got the opposite of everything I started with. All right, on to this one. A negative number to an even power. Positive or negative? Positive. So here when I square this negative x, it becomes positive x squared. What's positive x times negative 3? Negative 3x squared. And then a negative 1. All right, we have to compare every single term in the original function with every term when we plugged in the opposite of x. How do they compare? They're all the same. So how would I describe that in terms of the symmetry of the function? We would say this function has even symmetry. And the reason why would be because when we plugged in the opposite of x, we got out the original. All right, you try C. So in this one, we plug in negative x. The first one becomes positive. The second one becomes positive. The third one stays negative. And the last one is negative. So, same, opposite. Same, opposite. Did they all stay the same? Did they all switch to the opposite? Neither. Okay, which term? The 4, the 3, the 2, or the 1?
The 3.
The 3. Okay, so negative x to the third.
I got it now.
Okay. Is that?
So the x is
Yep. You got it. Okay, so questions about symmetry. Not too bad. Okay, let's look at the back because this is complete review. Woo! We did this last unit. But this is a characteristic of a function. So we're looking at the characteristics of our polynomial functions now. And it is this one. of functions. End behavior of a function describes what happens as the function approaches, as x approaches positive or negative infinity. Is the function increasing? Decreasing? What's going on? Remember our ends? That's all this is. So, now this is a different even. This is talking about the degree of a function. That is not even symmetry. Two different things. So, if the degree of a function is even, like it's y equals x squared, y equals 3x to the 4th, if that is your largest term and the degree is even, the power is even, then the ends do the same thing. Okay, so if the degree is even, the ends do the same thing. Or I could say the ends go in the same direction. That would be more mathematical. All right, if it's odd, what happens to the ends? The ends go in opposite directions. I really kind of like the direction thing. The ends go in the same direction. You don't have to change yours. All right, so if it's even and positive, what are my ends doing? They are rising and rising. So I would write that as x approaches negative infinity, y does positive infinity. As x approaches positive infinity, y still approaches positive infinity. So if the degree of our function is even and we have a negative leading coefficient, what happens? Both ends go which way? Down. So if it's negative, we're going down. If it's positive, we're going up. So this would be as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y still approaches negative infinity. Both ends go down. All right, if it's odd and positive, we can think about it as that line. It's going to go down to the left and up to the right. So as x approaches negative infinity, y does too. And as x approaches positive infinity, y also does. It falls to the left and it rises to the right. And then the last one is an odd degree with a negative leading coefficient. And guys, in the first part of Unit 1, we had to do this because you had to know these things to be able to graph. You guys did really well with that. Today's the last day for juniors. If you're interested in taking the PSAT here at Stars Mill on October 11th, it's your last day to sign up for that in the guidance office. There is a $20 fee if you don't have money today, but you're interested, you can go talk to him. I don't know. Yeah, let's swing by there. and ask. The reason we have to register is because they have to order enough tests, and you have to order them a good bit in advance. So, all right. So this one, the ends are going the opposite direction. If the ends are going the opposite direction, we know the degree of the function is odd. So we know it's odd degree. And then this one, the left side is rising, the right side is falling, so it would have a negative leading coefficient. Now, we know this has 3 roots, don't we? So, more specifically than odd, we now know this one has a degree of 3. The ends are doing the same thing. Even degree or odd degree? Even. And both ends are going down. So tell me about the leading coefficient. It's negative leading coefficient. All right, now, this only crosses twice, but does it look like a parabola?
Yeah.
Do parabolas do that? No. This is at least a 4th degree. It's got some imaginary roots in there. Okay? So we can't really state what this one is. It's doing some fun craziness in the middle. Alright, this one. What are the ends doing? Opposite, so it is odd. And it's falling to the left and rising to the right. Positive. All right, so on these, without looking at the graph, we should be able to state as x approaches positive infinity and as x approaches negative infinity, what is y doing? What is y doing? So for each of these, we should be able to complete this statement. I cheat a little bit. Okay, so let's look at it. Largest degree is this one. So this is the term we're looking at. This term is odd, and it has a positive leading coefficient. Oh, I did all of those backwards. Let's erase all that. I don't like to do it backwards. It really doesn't matter which order you go in, and it's not really backwards. They're both acceptable, but I like going left to right. I just made all of these go right to left. Okay, so odd and positive leading coefficient is going to fall to the left and rise to the right. Okay, luckily all these are in standard form, so whatever comes first is the degree of the function because it's the highest one on all of these. So this one is odd, but it has a negative leading coefficient. So what would that tell me? As x approaches negative infinity, what does y approach? Positive. And as it approaches positive, y approaches negative. All right, you try number 3. Alright, so this one's even, and a negative leading coefficient, so it's the same, and it's both going towards negative infinity. Alright, so that's it for today. That is all we're going to cover today.